Okay, so we're going to talk about operations on rational expressions. And a rational expression is just a fancy way to talk about fractions. So everything that holds for fractions is going to hold for rational expressions. What makes it an expression is we're going to have things like x and y in it where we have to do more abstract combination of fractions, but it's still the same rules that apply as before. So let's say that we were asked to simplify the following. If this was a fraction, we would look for common factors and cancel those common factors. It's the same thing. We're going to factor as much as we can, and we're going to look for anything that's common between them. So our numerator becomes the quantity a plus 1 times quantity a plus 1, and the bottom becomes 2a plus 1 plus 1. We see that we have an a plus 1 in common, which means that we can cancel those and go to there. And we want to keep in mind that just because we have the plus 1 on both sides, can we cancel that? And if I have a's on there, can I cancel those? I can't, because there's addition between them. So I can only cancel when I have just multiplication linking my terms. If I have addition or subtraction, I cannot cancel them. Alright, so that's a pretty simple example. We also have what are called complex fractions. So a complex fraction is a fraction of a fraction. And the same rules that we had before are going to apply here. So if we have this rational expression divided by another rational expression, what we want to do is to take that denominator, the 6 plus x minus x squared over the 4x minus 12, and get rid of it, make it equal to 1. And the way that we do that is by multiplying by the reciprocal. And so the reciprocal is the fraction turned around. So I multiply the bottom by the reciprocal, and to keep the quantity the same, I have to multiply the top by the reciprocal as well. So my numerator now cancels out. That's a big fancy way to write the number 1, which is why my expression isn't changing. But the what it looks like is. So those cancel, and I'm left with this top piece that I have to deal with and cancel any like terms. So this is like the one we did before, where I'm going to factor things and look for things in common to cancel out. So I notice that I have a 5 in common and a 15 in common for my first fraction, my first rational expression. And then I have a 4 in common and nothing that I can factor on the bottom there. And so I'll notice that I'm very close to having terms that are the same. But x minus 3 and 3 minus x are not the same. And x squared minus x minus 6 is not the same as 6 plus x minus x squared. But I can make them the same by pulling out some negative values. So if I was to take this, and as opposed to factoring as I had, I factor out negatives, I'm going to get terms that are the same, and now I can cancel. And so I'm going to, now that I have it set up, I'm going to cancel everything in common. So those go away, and I'm left with positive 1/3 times 2/3, which is 2/9. And that is my reduced complex fraction. Okay, so that's multiplying and dividing them. Again, same idea as fractions. We can also add and subtract them. And to do that, we're going to need a common denominator, just like we would for any fraction. So we're going to find a common denominator and add or subtract these. So for example, I have this value, and I could always get a common denominator by just multiplying denominators, but it's not going to be the least common denominator, and so I'm going to have more work at the end if I don't find my least common denominator to begin with. So I'm going to factor as much as I can and see what I need in common. So I'm going to factor that denominator, and it turns into d plus 2 times d plus 2 all over. And so if I want to get a common denominator, it's going to be d plus 2 squared. I'm missing that value of d plus 2 on the second fraction. So I'm going to add it there. And I can't just add it to the denominator. I have to add it to the numerator as well. And now I have a common denominator. I can add everything together. So my final answer is 6 plus 5 quantity d plus 2 all over quantity d plus 2 squared. I could distribute the 5 if I wanted. It's not necessary. I've combined it into one rational fraction.